All right, so union and set difference, two other operations, relational operations. These also take two input relations, but these relations, these tables, have to be union compatible. What does that mean? So to be able to combine, to union or to difference two tables, okay, they have to have the same number of fields. So the same number of fields, or the same number of fields that have the same, also the same type. Okay, so it has to be that these two tables, like S1 and S2 in our example, they have to be, that's why we had them in the example, so that we don't want a straight union and set difference. So to do union of S1, union S2, all you have to do is to actually get that as if it's the summation of the two, not the summation. Let's keep with the definition. It's the union of S1 and S2. Okay, so as you can see, this is S1 and this is S2, and we have, you can see that the duplicates are removed. Okay. Set difference. In the set difference, we have actually to subtract two tables. So S1 minus S2. Okay. So S1 minus S2, that would give me S1 minus S2. All right. So this one minus this one, so 31 and 58 are going to be removed. We'll be left with only one double. Okay. S2 minus S1, so we'll be left with two doubles, I suppose, 28 and 44. Okay, and as you can see, the two tables are the same. Okay, have the same fields and the same types. Cross product. Okay, so the cross product, we said that each row of S1 of the first table is combined with each row of the second table, and the number of rows would be, of course, the number of rows of S1 times the number of rows of R1. The result schema has one field per field of S1 and R1, so we'll have as of the number of fields. If this has five, let's say, and this has five, or this has five and this has three fields, then the result will be 8 fields. So all the fields will appear. Okay. You may have a naming conflict, which means that both of them have the same name. Let's say you have SID in one table and also SID in the second table. So what you can use is this operator that is used in order to change the name. So we change the name of the first field to SID1 and the fifth field to SID2, of which cross product S1 times R1. To understand this, let's look at this example. This is R1 cross product with S1 to do the cross product of S1 and R1. Okay, so we'll get this. So all the fields, for 4 fields, appear here. Okay, each, so S1, each row, each row of S1, okay, will be combined with each row of R1. So this is the first row of S1, this same Dustin one, okay, with the two rows. That's the first row 22, and then we repeat it with the second row, which is what, 58. Okay, 31. Okay, as well, we continue it from this table, 22, 58. So this is the cross product of S1 times S1 and R1. So we're saying that the SID, okay, we could change the field name, okay, of the first column. This is 1, 2, 3, 4, and the fifth column and 5. We can make this SID1 and this is SID2. We have compound operators. That is an operator that includes more than one operator inside it. For example, the intersection. So these are operations done on operations. Okay, that's multiple operations. We're saying that they don't add the computation power to the language, but are used for shortcuts. Okay, like let's say for simplicity, instead of having, for example, instead of having r minus s, we do we do r intersection s. So that's what we mean by operators that are useful as shorthands. Okay, so instead of putting these two operations here, minus minus, we only put intersection. So it takes intersection because it's using set difference. Also, the two input relations have to be union compatible. It is have to have the same number of fields and the same types of the fields. Okay. So this is S1 and S2. Then S1 intersection S2 is like doing S1 minus S1 minus S2. Okay, so you do S1 and you do this. So this is the intersection of this one. This one apparently is the intersection, which is the common tuples in S1 and S2. Another useful compound operation is the join. Joins are compound operators involving cross product, selection, and sometimes projection, as we shall see. Most common types of join is a natural join. What do you mean by natural join? So what do? You compute R times S, R cross product S. The cross product that we talked about, which is the combination of each row of R with each row of S. Okay. Then you select rows where the attributes that appear in both relations have equal values. So you take only the common ones. Okay, that is as if you're doing an equal condition. And you project all unique attributes and one copy of each of the common ones. So that's how the join works. So let's see by an example exactly what's happening. If this is R1 and this is S1, then S1 join with R1 will show me, okay, only the common ones. So we do cross product. So this is simplification of the cross product. It's less than the cross product, as you can see. We only show the useful ones, which is the useful ones, which is S1, this part, okay, combined. It's going to be combined will join. Sorry, it's going to be a compound will combined with cross product with this one and this one. But this one is to combine 22 Dustin with 58. It doesn't work. We don't need it, so we do only with the one that's equal to it. So we combine it only with the first row. Okay. So this is 22 Dustin 7, and this data is for definitely for Dustin. Okay, so we don't need all the combinations. So this is better than the cross product. And the rusty one, okay, is done in the same way. So this is the join operator. Very clear. We're saying here that there are other types of join, not only the equal. There is a condition join, so you join them on a certain condition. Okay, if the tuples have satisfy a certain condition, then they're going to be included in this join. Okay, which is equivalent to actually. So when you say table R join or condition with table S, it's as if saying a selection on a certain condition on the cross product of R and S, and that's how it works. Okay, so you cross product R and S and you take only the records that you need. Okay. So this is an example of S1 and R1 where S1.SID is less than R1.SID, for example. Okay, maybe this we need such information. So as you can see, this SID is 22, this one is 58, this one is 31, and this one is 58, and definitely this SID is less than this SID. So we're saying that you still have the same schema, the table didn't change, the same schema as the cross product, okay, but we have fewer tuples. And we have equijoin where only for equalities, you can do it for equalities, okay? So we can put less than or greater than, so only equal. Let's take an example of another example. So we have boats, we have sailors, and we have reserves, okay? Let's say I want to find the names of sailors who have reserved boat 103. How would you do it? So I want to find the names of sailors that took boat 103. How would this work? I hope you thought like this too. So we would do, usually we did this first, okay? So select from reserves, BID equal 103. So we select from reserves only 103 boats, the boats that have 103. You select it from reserves and you join it with sailors. And remember, this is the natural join, which means only the sailors of 103 are going to be joined with sailors. And then I'm going to project, finally, we project only the S name of those people. Okay. This is another solution, okay, where you do join of reserves and sailors, and then you select BID equal 103. This will give you the same. It will give you the same result. But maybe solution one is better. Another one is, let's say, find names of sailors who have reserved a red boat. Okay, so let's see again the example. So we want to find the sailors who have red boats. So red boats, we have to get back to boats to figure out which ones are red. Okay, and then we have to link it to sailors and reserves. So information about that boat is only available in boats. So we need to do an extra join. All right, so what do I join? We said that final step is the projection. So we select on color equal red of boats, okay, join the, okay, after you get those, select, what do we select? So selections again is we select certain tuples, rows, okay. We join, natural join with reserves, and then natural join with sailors in order to get what? In order to get the information of the boat number here, and then the sailors, we have to get the sailor's name, okay? And then here you do the projection on S name, only S name will show. We're saying here that there's another a simpler, more efficient solution where not as many roles are going to be worked on. Here we have more number of rows before we get the S name. In here, you only need the BID, the boat ID, in order to get information from reserves. So you only need the boat ID. So you project. So the difference between this one and this one is that after this step, you project only the boat ID because that's the only one that I need from reserves, and you do that with the reserves join. Okay, so we're going to see information of those boat ID which were red only. The same thing here, but here we didn't do a projection. All the rows appear, all the columns appeared. So projection of boat ID, join with reserves, and then I only need from those, I only need the SID of the sailor. So I don't need all the other columns. So SID join with the sailor, and then we can project only which information do I need. I only get the information which is S name. This should be very simple for you. If this is difficult, please contact me because this is very simple. I advise you to actually have the tables in front of you and look at them, review the join and the selection and the projection, and you will find that this is straightforward. So we say that the optimizer will do the first solution. Now find sailors who have reserved a red boat or a green boat. Same thing will apply, but now with the selection I put an or here, okay? And what I did, you can use this or you can omit it, yani, which is allowing me to do a temporary boats. This is it will result in a relation called temporary boats, and I put it here. I could have otherwise. So this is the same as we did before, the same as the previous slides, but now instead of only color equal red, I have color equal red or color equal green. All right, and I put them in temp boats. I could have this, all of this, put it here instead of temp boats. You can do both. Okay. That's it. This is the relation algebra part of the course. It's important to understand that these are the basics. This is, later on when we study query language, it's important to know the mathematical background that the query language is based on. Okay, please, any inquiries, don't hesitate to send emails and ask. And please study and do the practice with the lab instructor. Thank you.